All right, number 13. Find all values of x that make the equation true. If there's more than one answer, separate them with a comma. Great. So on the right-hand side, we see that we have a rational function because there's a variable in the denominator. And just to be consistent with how we're thinking about this, let's make the left-hand side also into a rational by dividing by 1. We said in order to compare fractions, we need the denominators to be the same. So this denominator has a 1, it needs an x. And if we multiply the bottom, we got to multiply the top by the same amount so the value stays the same. On the other side, you don't actually have to do this in this problem because it's just a 1. So 1 times anything is just going to keep those the same. But if you want to just follow that same habit that we keep doing, we'll say put the 1 over here. So now we have x times 1 and x times 1 as our denominators. Now the denominators are the same. Right. And what we said was we cannot divide by 0. So since we can't divide by 0, we can't have a total in the denominator of 0. So the 1 is fine, but this x can't go to 0, because if we do 0 times 1, that'll give us a 0 in the denominator, and that's undefined. So in this example, x cannot equal 0. Once the denominators are the same, we can then focus on the numerator, exactly. So now we will multiply this out and set it equal to this, which is just multiplied by the 1, okay? So think of every fraction as being in its own set of parentheses. So here we'll say x times x plus 2. Got to distribute the x. X times x is x to the second power. X times 2 is 2x.
Why would we x times x?
Because parentheses next to parentheses indicates to us that we're going to have to multiply this times this. And then because of the adding in here, that tells us we're going to have to distribute this. So this left-hand side is done, and the right-hand side, 1 times 6x is 6x, and 1 times negative 3 minus 3.
So we just bring it down.
This you just bring down. If there was something different here, you'd have to show the multiplication, right?
So we'll do 3 times 1.
Yeah, negative 3 times 1 is negative 3.
But if something else would do, we'll do negative 3 times something else.
Right. Now, this is quadratic, and we said we solve quadratics by setting the total equal to...
Wait, why is it x to the second power? Is it 2 right there?
This is x to the second power because of x times x. Hey. And because this is quadratic, to solve it, we need the total to be equal to 0.
You said the what?
Because it's quadratic.
It's quadratic with 0.
We solve quadratics by setting the total equal to 0. And the way we get it to 0 is by doing inverse operations. So inverse operation on the 6x is, right.
And then you cross it out.
Yeah, but before you cross it out, I'd recommend you make sure you write it over on the other side too. Yeah. Now you could cross it out. And then inverse of negative 3 is plus 3. And that means we have to add 3 over here.
Sorry. A negative is inverse. It turns out positive.
Yeah, and that should make sense because we would say negative 3 plus 3 is 0, which is what we're looking for here. Okay, so now we got to combine like terms here. X squared, bring it down. 2x minus 6x is minus 4x. And then bring down this 3. It's 0 plus 3 is 3. Now we have a quadratic equal to 0, and in class today we called this easy factoring because this is just 1x squared, so that should be pretty easy. We can show a box if you want. We try to solve quadratics by breaking it into factors and then setting each factor equal to 0. So if you wanted to see the box on this, right, it would be like this. X squared and plus 3. So that's that x times x. Then we need some combination of this and this so that they multiply to equal positive 3. But when you add them, they add up to equal negative 4x.
It's not the inverse.
So some amount of x, some amount of x, so that the total, this x plus this x, is negative 4x. If we wanted to annotate a little bit more, we could say blank plus blank is negative 3.
What is?
Sorry, negative 4.
Something like the thing you on the diagonal, but we don't know yet. We gotta figure it out. What question is this?
13. Okay, so something times something is 3. That could either be positive positive or it could be negative negative, right? So what are our choices for something times something equals 3? So let's see 3 and 1. So positive 3 plus positive 1 would be positive 4.
Oh,
So,
I thought we were doing negative 4.
yeah, negative 3 plus negative 1 is negative 4.
Oh yeah.
And negative 3 times negative 1, negative times negative is positive. So this is what we want.
This one right here, negative 3, negative 10.
So that means this could be minus 3 and this could be minus 1. X times negative 1 is negative 1x. And x times negative 3 is negative 3x. So now you can see that total negative 4x right here.
Because x is 1.
Because this naked x is negative 1x. So then we could say the factors are x minus 1 and x minus 3. And what did we say we're going to do to the factors? It's pretty simplified, right? You've got your standard form here. You've got your factored form here. So it says factor times factor equals 0. So this will be true if we can get this factor equal to 0. So we could say x minus 1 equals 0. Then the same thing, if we could get this to be 0, you'd have something times 0 is 0. So do x minus 3 equal to 0. Finally, inverse operation to get x by itself.
We're doing inverse operation now?
Yeah, to isolate x.
Why are we isolating?
Because once x is isolated, that's our answer. It says find all the values of x that make this true. So our answer should be x equals something, and if possible, x equals something else. Because it says find the values of x that makes this true. At the end, we can plug that back in to check them. Okay? So x minus 1 equals 0. What's the inverse on this so that we can get x isolated?
X minus x?
you want the x to stay here, but you want the negative 1 out of there. So you got to do an inverse operation on the negative 1.
Positive.
Right. Do it to both sides. Negative 1 plus 1 is 0. Cross it out. 0 plus 1 is 1. X equals 1 looks like it's an answer. And now, inverse operation on x minus 3.
Now,
We got to isolate x here.
find this 3. on
Yep.
both sides.
Add 3 to both sides. X equals 0 plus 3 is 3. Mhm.